castaways. We are castaways. Ahoy there, ahoy. We are castaways. We're stuck where we are, with no house, no car. Castaways, ahoy. We are castaways. We were out.
Application of differentiations. So what is differentiation? Differentiation is an algebraic method of finding the derivative for a function at any point. The derivative of a function is rate of change of y-axis with x or slope at a point. Okay, then what is differential calculus? Differential calculus is a study of rates of change of function using the tools of limit and derivative. What is rate and related rates? Before we know about related rates, I will explain just a short explanation about rates. Rate is speed of change of a function, or we know as dy over dx. Okay, what is related rate? In related rates problem, the idea is to compute the rate of a change of one quantity. The procedure is to find an equation that relates the two quantities and then use chain rule to differentiate both sides and with respect to time.
Why we use differentiation in related rates problems? Okay, this is because differentiation can help us to solve many types of real-world problems. It being used to study the small change of a quantity with respect to unit of another. Thus, it means differentiation can finding the rate of change with respect to time. Therefore, the respect to time terms is so relate in the related rates problems because it involves with the time. For example, it allows us to finding the rate of change of velocity, and also we can find the slope of a tangent to the function at the point. So, differentiation is so important to help us in a many of calculation problems.
Problem statement 1. A spherical balloon is inflated or expanded at a rate of 900 cubic centimeter per minute. So how fast is the radius of the balloon changing when the radius is 12 centimeter? The current issue that can be linked to this problem is when pumping air into a birthday balloon during birthday party celebration or any special occasion.
Step 1. We need to make a list of the information that we have. Step 2. We need to know what is our goal. Our goal here is to find the R over dt. R is given is 12 centimeter and the dt is 900 cubic centimeter per minute. Okay, then we continue with step number 3. Step number 3 is we need to write an equation that relates the volume of a sphere to the radius. Volume of sphere is 4/3 pi r cube. Okay, now first, dv over dt equal to 4/3 pi 3r square dr over dt. Where to get 3r square? It is from r cube. We differentiate r cube. So we cancel out number 3 because it's same. So our equation will left as dv over dt equal to 4 pi r square dr over dt. So we know the value of radius is 12 centimeter, right? So just substitute it back to these equations. dv over dt equal to 4 pi 12 square dr over dt. Okay, then we continue again. We substitute the value of dv over dt. dv over dt is 900. So just put it again in the equations. So when you already isolate the dr over dt, you can solve it by using your calculator. So by using our calculator, we can know the value of dr over dt. dr over dt will equal to 25 over 65. So our final answer for dr over dt is 25 over 65 centimeter per minute. Therefore, rate of change radius balloon is 25 per 60 pi centimeter per minute when the radius is 12 centimeter.
Therefore, this kind of problem statement can be solved by the differentiation method. It can be used for solving this first shape of balloon that being applied on the birthday party in the real life. Okay, another example of application in real life, also we can calculate the rate when the soccer ball is pumped with the using ball pump. So the application of the differentiation is proven in this problem statement. Problem statement 2, which is the water is moving into a conical vessel of semi-vertical angle 45 degree at the rate of 9 cm cubic per second. Find the rate at which the water surface is rising at the instant when the depth is 3 cm. So why we choose this kind of question? Okay, this is because this problem statement so relate in the current issue now that happens in the real life. For example, like the water tank that have shape in cone that being used as the storage of water. Usually it being used in our house, in the school, in the office or any buildings that need the usage of water. So this water tank in cones are so beneficial and important for human to make their life more easier. So we can relate this application to the problem statement that we choose, which is we pour the water in the cone tank, so the water is rising. So we need to find the rate of water rising when the depth is 3 cm. So within the angle, we can find the radius and the height with using trigonometry formula.
So I am going to use the chain rule method. So first thing first, you have to write the value from that has been given from the question, which is dV over dt is 9 cm cube per second, and then you have to write the equations what we want to find, which is dH over dt and when h is 3 cm. Okay, for second step, you have to write the volume of cone, which is 1 over 3 pi r square h, and then we simplify it by proportional. We eliminate one of the variable, which is r is equal to h multiplied with tan 45. Tan 45 is equal to 1, and then you will get r equals to h, and then you substitute it into the volume of cone, and you will get 1 over 3 pi h cube, and then you differentiate it, you will get pi h square, and then you substitute the value of h, which is 3, and you will get 9 pi. So after you get 9 pi, you have to invert the equation because we want to find dH over dV. So you will get 1 over 9 pi. And after that, you use the chain rule method. You write the equation that what we want to find, dH over dt is equal to dH over dV multiply with dV over dt. So you just replace the value from the previous working. You will get 9 over 9 pi, and then you simplify it, and you will get 1 over pi centimeter per second. Therefore, water surface of the conical vessel increasing at rate 1 over pi centimeter per second when the depth is 3 centimeter. Therefore, this kind of problem statement can be solved by chain rule method. It can be used for solving this conical shape of vessel that being applied on tank house. Another example of this application in real life is beer fermenter tank conical cone bottom. So the application of differentiation is proven in this problem statement. Related problems include finding in the differential calculus a rate at which the quantity changes by relating to other quantities with a known rate of change. The change rate is usually time-based. Many methods can solve the related rate. For example, we can use the chain method and also the long one way. For the long way method, it has to sketch the physical situation first and then look at the diagram, create an equation that connects the variable of interest. Take the derivative of both sides of your equations concerning time. Keep in mind the chain rule too. Finally, solve for desired quantity. The related rates are so significant since there are so many applications of the real world.
Last but not least, I want to thank me. I want to thank me for believing in me. I want to thank me for doing all this hard work. I want to thank me for having no days off. I want to thank me for never quitting. I want to thank me for always being a giver and trying to give more than I receive. I want to thank me for trying to do more right.